Hi, and welcome to this session on getting started with C# and AI using semantic kernel and Azure OpenAI. We are now at bonus 6 video, which is about the Much Type Model Context Protocol, or MCP. So Model Context Protocol, or MCP as we'll call it for the rest of the thing, is, as it says, a protocol. It has nothing really to do with AI, but more how AIs talk with tools. You can call it function calling as a service. So it's all about that you can make some servers. They can either be local or remote. We'll see both. And they can expose what they offer and what they can be called. And then you have your normal AI client that uses AI. The server can technically also, but not the most important part here. But the client will be configured to have one or more MCP servers that then can tell what they can offer. And based on that, you can do the various function calling, so you don't need to build every single feature of function calling, for example, GitHub, Microsoft Graph, and so on into this. It can be done using the server. It is still very early days for MCP, so there's a lot of things that's not working yet. The spec is not finished, but given that it is so hyped right now, which is, in my opinion, too hyped, then we will still go into this. Regarding semantic kernel, it has very little to do with semantic kernel as such. There's some other NuGet packages we're going to use in order to do the MCP part. But because this is a series on MCP, we are going to see how it relates and how semantic kernel can use it. So let's jump into some code. And here we have a little solution called MCP with a client, a local server, and a remote server. And we're going to start with the server because without a server, the client can't call anything. And in here, we can see that we're using extension hosting, the model context protocol, which you can see is in a very early preview, and semantic kernel. Semantic kernel is only here because we are simulating that you have some function callings, meaning kernel functions here, and we want to turn them into MCP tools. If you don't already have these for semantic kernel, you don't really need to use semantic kernel at all on the server. But let's just say we had made a lot of tools that are very important to us and we want to expose them as MCP. That is the reason why we have this here. So I have one class with two tools that the one is just responding and the second one have an input that it pings back to the system. So nothing fancy here. And in here, we are going to make a host application builder because this is just a console app. And we are going to use the semantic kernel because we want to have imported our function calling tools, our two tools, tools 1 and tools 2 in here. And then we are just using MCP server tool.create on the two functions that are in here. So we end up with two MCP tools here. And beyond that, we just say add MCP server with this Studio Transport server. This is local transport using gRPC as far as I understand it. It doesn't really matter for us. And we are telling it has these tools. You can also give other things to MCP, resources and prompts and stuff, but it's not really what people are thinking about when they're talking MCP. They're talking about what tools can you add. So in this case, we are just making a server that has some tools. And if we run it, we can do that, but we're not really going to see anything. We're just getting that we have started, and behind the scenes, this is now an endpoint that can be consumed by an MCP client. But we're not really going to run it, because when it's local, you instead let the client run the local server, meaning we are going to spin up this code and then consume it. So you don't really do this. End of the day, this is just an executable, but so we can either build it and run it, or run that executable, which is what we're going to see now. But there's nothing more here. And again, we could have made the server tools using just MCP if we hadn't used kernel functions. Let's move on to the client, which we're going to switch to here and see that. So I've made a small configuration so I can get my Azure AI endpoint and key, but beyond that, we're just gonna have some various scenarios. And the first one is that we are gonna call my local MCP as a client, and this client here, as you can see, is using the protocol and semantic kernel, but nothing more than that. So we're going to go into the first scenario here, where we can see that what we're doing is we are going to make a client, and it's this stdio client, where we are going to tell, hey, in order for you to get this tool, you need to build this C# project. So we're going to call .NET Run with project C#. This is not really what I would do in real life, but I've taken this into account because this is the default example that semantic kernel uses as well. But so what is going to happen is we're going to build, essentially just hit the code, build it on the fly, meaning we need .NET on this machine in order to run this code. And then we're going to make a client. So let's set a breakpoint and run it. This can be confusing at first, but it will make more sense as we go along. But we're going to build our client, and it built the code, and now behind the scenes this is hooked in and connected. So what it can do is, if we go down to this, is it has a method called list_tools_async. So we can go in, get the first tool. The first tool was called myServerTool_tool2. That is the semantic kernel way of calling tools, but you could give it another name if need be. And you can get the description of the tool. So this is the discovery part of this. So we can figure out there was two tools. And if I find this, it shows that. And then we can call the tools, meaning we can just say call tool async. And this is not something we would do in real life. This would be the AI doing that. So we'll just tell this, the AI, hey, you have these tools available, call them as you want. Because the tools as well also tells what kind of parameters would they need. So we can call the client and we can say call tool. And that will give us back a content with some data in it, where we come back with the response from tool 1. So if we look at this, it would come back. So we have essentially now run a client that built the code, made the connection to it itself, and then called it by getting the tools and the system. So absolutely no AI involved in this right now, because again, it's just a protocol. Let's switch to example number 2, which is we can also just do this as an executable. So this is more or less exactly the same code, but instead our command is just run this executable, which is the output of this tool. So you could provide an executable to a person, and then you could use these tools, because what we're doing right now is consuming them. But inside Visual Studio Code and Cursor AI and all these things, you can also tell, hey, I want to have this tool, I want to have this tool, and you have the option to say, I want it to be a local tool, and here's how that tool is instantiated and run. So if we set the breakpoint here and run the code again, we'll see exactly the same thing. Now it's just in the built version of the local server, which is just an executable. So we will list some tools there, and we can call the tools just as before. So this is probably a more normal way if you have built your server as an executable and are using it locally. Let's see how to consume it in a bit more advanced way, not with this little tool, but with a more real use case scenario. So GitHub have made a local version of their MCP server. They have not used C#, they have used Node.js to do it. So if we look at this now and run it, we'll see a more real-life example on what's going on. So in order to build this, we use npm or npx, which is the command to do this. We give it a parameter /y. Honestly, don't know why it's that. And then we tell, hey, give us the Model Context Protocol server GitHub. So this is like on the fly, getting a small Node.js tool and running it. So a little like building the C# code on the fly. It's not really something we see anywhere. It's just there. And once we have the connection, we can now list the available tools. So the available tools for the GitHub is to create a file, search the repository, create a repository, get file content, list issues, and all kinds of things that we can do with the tool. And this code you don't need to write. In the real life, before you would need to find OctoKit, which is the NuGet package for GitHub, and so on, and build all this code by yourself. Which you sometimes still need, because one thing about MCP right now is that it don't know anything about authentication. So we couldn't use this GitHub tool to go to a private repo. It can only go to public things. So this is more or less a small demo. We're not even giving a token, so we can get higher rate limits and so on. So it is kind of, just a gimmick to try and use. But essentially, all these tools are here. And the definitions of them, how you need, what different parameters they need, and so on. So in this case, if we just have all the tools, see the 26, and we can, for example, go in and see the list commits here, where it also goes in and give us the schema of this, where it also tells what different properties it needs to be called with, what is required, what is and so on. So if we look at this in system here, this is the schema for that specific tool, how to call it. We need to give it an owner, we need to give it a repo, and so on. And this is exactly what a an AI needs to have. So now we're using semantic kernel to say, give us, add all these plugins or tools or function calling, whatever we call them, into the system. So we're just taking all the tools that the MCP server have and turn them into kernel functions. Semantic kernel have made that is easy to do. So when we do this, we now have a tool that has 26 functions in that we can call. So essentially, that would have been the same as we have gone and made these 26 ourselves, implemented behind the scenes how to do it using GitHub. So now we are just building an agent, and we are gonna use function calling. Let me jump here so it's easier to see. And the only thing special about MCP is there's this retain argument types. Before I used function calling, I had never seen that used, but because MCP uses this schema and not a C# class to define the functions, it seems like retain argument types is a good thing for the system, because I saw when I didn't do that, it got some of the arguments that need to be called wrong. So it perhaps when it needed to send out how many number of data should come back, it might give it as a string instead of an integer. So putting this in just essentially it actually works without it, but it will do a lot of mistries, and semantic kernel will redirect and figure it out after the fact. But if we go in here and just let the system call the system, so now we're getting our response back. I think, yeah, I haven't gotten it yet. So now we have the response back, and what we can see is we get, in this case, the prompt was summarize the last 4 commits to the Microsoft Semantic Kernel repo. So based on this, AI found out, hey, I need to use the GitHub tools. I need to put in the owner as Microsoft, the repo as Semantic Kernel, and I need to get 4 of them. So what it did was, if we look at the history of this AI interaction, is we gave it the system, and it made a tool call, and the tool call was use the function called GitHub-list commits. Owner should be Microsoft, repo should be semantic kernel, and per page, meaning we only need 4, should be 4. And if we look at what happens then, the chat history, it comes back with the raw content in here, like normal function calling, and then it used its normal AI features in order to summarize it. So if we run it here and see the system here, it did a summary of the last 4 pull requests. So this was without us ever writing a single line of GitHub code. We're just using the GitHub server. Moving on, this is all fine if you run everything locally and so on, but let's imagine you have a tool that you want to expose to the world. And GitHub could expose this instead of a local Node.js tool. They could expose it as an endpoint, but that endpoint would, of course, get a lot of traction and so on. So right now they have not chosen to do that. So MCP is kind of a local thing, but it can be done remotely. So what I've done is I've tried to build a remote server instead of a local server. And remote meaning it's just an ASP.NET Core system. In my case, minimal API, but nothing special. And in here, we are doing exactly the same. Instead of modal context protocol, we're using the sub NuGet package core with ASP.NET Core, but nothing else really here. And we are using exactly the same tool, so nothing special there, just a copy paste here. And in here, we are taking the web application builder we do exactly the same code here as we did in the local, and almost the same here, but instead, as we did up here, called add MCP server with SDO's thing here, we are then instead saying add MCP server with HTTP transport instead. So essentially, we're just exposing it to the system, and then we are mapping MCP. We're going to see what that actually means in real life in one second. And in order to run this server while also running the client, I just have spun up a new Visual Studio here with the remote server on. So just the same solution open up twice, so it's easier for us to run. And now I'm just gonna run it. It's not really something you can debug in an easy way or anything. It just comes up as a normal system. And the URL to hit it is actually /SSE for server-side events. But we are just gonna let this run in the background and see how we use it in the client. So here we have the same as before, but where we used a studio transport, we are now going to use a client transport. And a client transport instead takes an endpoint instead of a command and some arguments. And in this case, we're just hitting my local /remote. Now it's as a service, as an API, whatever we call it. And then /SSE. And if we do that and run it here, and again, my server is running here in the background, but we're not going to see any breakpoints or anything in it. So if we run it here, oh, I need to not run the GitHub version. I need to run the mine remote. There we go. So we hit our breakpoint. There we go. And we're just building a client just like before. So the transport is the only thing that is different. Beyond that, we're just getting our tools. In this case, our tool number 1 and tool number 2. Apparently they can come in any order, but it doesn't really matter for an AI, of course. And we can call those tools as well. So if we look at the server, yeah, it will just call the tools. So now can do it over an HTTP call instead of this local stuff. And the last one, nothing major there. It's just that I have now then put this up into a Azure web app. Could be a container app. It could just be something that have some kind of domain. And then you can use it in exactly the same manner, because now, yes, this was not remote because it was localhost, but it's essentially a different process that we are hitting. So that is actually everything. So if you want to build a server and either give it as an executable for C# or host it as something in ASP.NET Core, you can do that. If you want to be the client consuming it, like we did with GitHub, you can do that. Or you can just have the server and let Visual Studio Code's GitHub or Cursor be the consumer of your tool. It doesn't really matter because it's just a protocol getting back and forward, and then everything is up and running. So I think that was everything you need to know about MCP. I hope you find it beneficial, and see you in the next one.